Assalamualaikum warahmatullahi wabarakatuh and salam madani to everyone. My name is Noliana binti Rasidi and I am a final year student from Faculty of Civil Engineering, National Defence of Malaysia University. In this video, I would like to present my final year project with given title of Surface Erosion and Sediment Transport Estimation in UPNM catchment. For the first section of this presentation is Introduction, Objective and Problem Statement. Soil erosion is a global problem which has social, environmental and economical adverse effects. Soil erosion reduces soil productivity and water quality and has caused sediment to accumulate and the water level in the UPNM catchment to rise. Therefore, this study was conducted as an effort to estimate the average total soil loss and the total sediment yield in UPNM catchment, which transport from one location to another over a period of time using sediment delivery ratio. The study utilized from GIS and remote sensing to analyze the soil loss based on revised universal soil loss equation, which is Russell, and this model is one of the most widespread models are used for soil loss estimate. Next, this study research was located at Sungai Besi, Kuala Lumpur and cover roughly 2 km square with a combination of deciduous, evergreen tree and some undeveloped forest area in this catchment. Jump to the next section. The data sources for this research are listed in the flowchart. The proposed research approach was based on the sense data for a specialized understanding of the differentiation factor of erosion and the use of the GIS in the analysis and modeling of erosion and deposition processes. All satellite images were downloaded from the Earth Explorer website of the United States Geological Survey, USGS, and DEM from Advanced Spaceborne Thermal Emission and Reflection Radiometer (ESTER). The DEM has a spatial resolution at 30 meter times 30 meter, which we use to delineate the watershed and determine the LS factor and P factor. A Landsat image at 30 meter spatial resolution covering the study area and used to classify the land cover to determine the C factor. In addition, the soil database was downloaded from version 1.2 of the Harmonized World Soil Database (HWSD). It was used to define the K factor. The rainfall data used in the present study were collected from stations situated in the catchment to determine R factor. Here the result was show comparison amount of the soil erosion and sediment yield in two different years, which in 2016 and 2021, while in the middle map was show the SDR mapping. The conclusion, the annual average soil loss rate in the 2016 was analysed to be 0.95 ton per hectare per year and in 2021 is 0.33 ton per hectare per year. The second finding is the soil loss rate was forested area, hilly and steep slope area was prevailing to be risk area. The third conclusion is about 20% of the UPNM catchment had very high erosion intensity. The fourth conclusion, the soil erosion was worse in the monsoon season compared to the dry, and the last conclusion is the average slope drops as the watershed grow and sediment production per unit area decrease.
Last but not least, here are some perspectives that attach with this study case, which GIS integration allow rational management of a multitude of qualitative and quantitative data on the various factors of erosion. The second perspective is the elimination of the complexity and the interdependence of the parameters of erosion by crossing the layer information on the thematic maps of each factor calculated independently of others. The third perspective is data obtained is generally not in the same resolution and need to be updated. And the last perspective is spatialization, quantification, and calibration of the field data are essential and need to be accurate.